It makes you wonder, what tooling do they need to have in place to do that effectively? Like, the degree of collaboration, the degree of false starts and different directions and, even, like, preparing the data and iterating on that before they even try to train a model. Like, they don't say anything about this in the paper at all. I think they focus entirely on methodology and outcomes, but it makes you wonder, what does it look like? Because while most people aren't going to do this, most businesses that want to do some kind of AI, they're not going to be trying to train their own reasoning model, but they might be doing something of similar complexity. So that's kind of interesting to think about.
Yeah, I think in the niches, people are fine tuning. So the process looks kind of similar there. But you're right, like the lot MLOps to actually get to this level of quality.
Also think like it's also mentioned a bit later in paper. I'm not sure if someone else will mention it, that they have a couple of unsuccessful attempts. So what you're saying, that like they obviously didn't get there straight, is
Right.
actually highlighted in the paper. It's very interesting to see what they tried that didn't fit in the pattern.
Can I, it's in the chat. If from a high level, as I interpret what you said, if I'm looking at this as a big picture, what it seems that DeepSeek has done is instead of using billions of parameters, they've synthetically generated parameters from the chain of thought and substituted them back into the model. Would you say that's the basic notion of what's been done here?
Yeah, I think so. I mean, that's what they were doing with RL as well. But for R1, the only difference is, yeah, they have some of it is not just synthetic data, like some of it is also data sets that already existed, which they have used. So it's a combination of the two, but there's a lot of synthetic data that is being used to get to the good quality accuracy.
Yeah, it's basically they use the output of the chain of thought as parameters, basically, in my mind, is as I'm understanding what you said. That's cool.
Yeah. And so this is what I was interjecting, Adam. With this was my takeaway. Like, this long chain of thought is all you need to make like amazing reasoning, or at least as of today. And all of that shows up at inference time, which is all the rage about, hey, can we get like more money on that side? On experimentation side, there were some things that are useful just because like I run a lot of evals, and I think like a lot of the community here would be interested to know that as well of how they evaluated things. And well, the first thing is like, how do you even evaluate thinking? That's not straightforward. And so they shared some stuff of what they were doing, how that can be useful for evaluating thinking. So the first thing they did was, let's just turn on all of the maximum token output so that like the model is provoked to think longer and generate a lot more tokens. And then that will capture all the detailed thinking as well. The other thing they did was they tried greedy response, which is like they will take whatever the next token is and evaluate that, but that didn't work out well. So what they did was then they generated multiple outputs and they took the average of the correctness of all of those. And so that, and while generating multiple outputs, they didn't have a temperature zero, of course. They wanted variety in it so that the LLM can do different thinking so that then it can figure out like, okay, like, this is the right answer versus this. And how often is it able to think correctly? That's kind of how they evaluated NK in this case, of like how many responses are they generating per query. Um, so that's how they evaluated it. They did it across everything in the end with R1. R1 0 was mostly, again, coding and math, but then R1, they wanted to be more general purpose. And so here they took all the different coding benchmarks. There's so many. I'm not familiar with a lot of them as well, but the overall gist is that like they evaluate against different things. And then the quality is pretty good. Almost in all cases, this process got them to be better than the base model, which was V3, right? And so that was already a win. Where like with very little data and adding this like long inference time generation of tokens, you can surpass the accuracy of what you can produce for complex queries. So that was super cool to see. It was the whole rages. It was competitive with one latest update with much, yeah, like open source and all that. So that was the other thing.